Okay, if we went too fast this morning, just recapping, we should have our Pythag formula down and be very, very confident with using him or her. Well, him, I guess. We should have our 3 trig rules under control. Some of you might remember them from last year by the word Sokotoa. I have to remember the rules in order to spell Sokotoa correctly. Okay, and it all comes down to being able to label your triangle properly. So if this is your angle of interest, here's your right angle. The one that's opposite that is your hypotenuse. Here's my angle. That side that's opposite the angle is the opposite side, and of course the leftover one is the adjacent. Okay, and there are only 3 types of trig problems that you can get, and not because you've got 3 trig rules, it's where the unknown is. So if we go through over here, we're going to, first thing we do is label our triangle. So this is my hypotenuse, this is the opposite, and this is the adjacent. Now look at what information is what side is no good to us. Now it's the hypotenuse because there's nothing there. I want to find the opposite side, and I've got information on the adjacent, so they stay. So what's the only rule that uses O and A? Well, of course, it's tan. So look up there and we write our rule down. Tan theta equals O over A. You sub your information in, so it becomes tan theta. That stands for your angle, which is the 40 degrees. Opposite is X, and adjacent is 7. Now, because your unknown is upstairs, we want to get X by itself. How do I get rid of a divide by 7? You times by 7. So X becomes, I'll say 7 times tan 40. Okay, you'll probably see that people will stop even writing the times. That's why we like to put that out the front. So you could just write 7 tan 40. I know, it's all about the less work, the better. Clearly, you can't write tan 40. Don't write tan 47, because then it looks like you're tan 407. So that's why we do certain things in a certain order. And then it's off to your calculator. We did say make sure that your calculator is in degrees, right? So on a graphics calculator, shift, menu, scroll down, and make sure, so you want degrees, so F1, exit. And then you can just type in what you see. Right, I'll leave that to you. So that's type 1. Again, it's all about unknown being upstairs. We do the next one, right? I love to start with my hypotenuse. Opposite the right angle, it's easy to find. Here's my angle, so that's hypotenuse. Here's my angle, and that is directly opposite. I don't have to bother labeling the third one because I've got 2 bits of information here. What's the only rule that uses O and H? Well, it's sine. So sine theta equals opposite over hypotenuse. We write sine. What is my angle? 15. What is your opposite? 9. What is your hypotenuse? Well, that's X. So you're not just randomly going, oh, 2 numbers, I'll stick the unknown upstairs. You have to go where the rule tells you to put them. Now, because the unknown is downstairs, what we're going to do is we're going to do the switcheroo. So we switch. The algebra behind that, I think you can see, to get rid of a divide by X, you times, and then to get rid of the times sine 15, you divide. So that's why we end up with 9 over sine 15. So you can see different calculations here. One's going to be a times, one's going to be a divide. So that's what we mean by this one is now type 2. So you've got one type of example, second type, and look, it's not the second because it's sine, and rather than tan, it's because of where the unknown is. Last one is type 3, and that is obviously now we've got an unknown angle, but we do exactly the same process. Here's my right angle, bang, hypotenuse. Here's my angle, that's the opposite side, which means this is the adjacent. Got information, no information, so I'm left with A and H. Oh, wouldn't you know it, it's cos. So, and cos is short for cosine, by the way. So cos theta equals A over H. sub your information in. I don't know what theta is. A is 9, hypotenuse is 22, and now to get rid of the cos, right, we use this thing called the inverse of cos, cos to the minus 1, so we go that of 9/22, and we find that just above your cosine button. It's in yellow, so we say shift cosine 9/22. Now I didn't have to use brackets because I used my fraction button. Okay, if I went cos and I went 9 and then divide by 22, do I get the same answer? Right, no good. So make sure if you're doing it like that, if you didn't use your fraction button, then you must use the brackets. So it's just little things you get used to, and that's how cookie crumbles. So that's the 3 types of questions that you can get with trigonometry. And now we're just going to pop them into combinations of questions. So I asked you to do question 4, but I didn't want to make this a massive video, so we'll just dive straight into 5. I'm feeling a change of colour coming on. Let's go with pale green. Okay, find unknown sides and angles in the following. So if we look at x, I don't need to use any trigonometry whatsoever. That's now going to be Pythag. So if I'm using Pythag, it's a squared plus b squared equals c squared. Now a and b aren't just the 2 numbers that you have, they're the 2 ones that make up your right angle. Now, oh, that's not good because I use a dark. Oh, I can use my black. So your right angle is here and here. So my A I'm going to call x, and my b, so x squared plus 3 squared equals 4 squared. I'm going to get rid of my plus 3 squared by subtracting. Notice I haven't, look, this could be 4.2 or 5.6. I haven't gone to my calculator at all. I just pop it all in there, and then I go the square root, and then I can hit my calculator. Okay, but what I'm actually going to do is I'm going to, if I do it on these ones, you can see 4 squared minus 3 squared, root 7. So I'm actually going to leave that as root 7. I'm not going to round off. Why? Because I'm now going to use that in my next question. So this is now root 7. So instead of rounding, I am going to, that doesn't look very nice. So now, because I want to find an angle, that means I have to use trig. Can't use Pythag anymore. So we label. That is the opposite, and this is the adjacent. So my rule is tan theta equals opposite. Oh, let's do that. Opposite over adjacent. Okay, tan theta. We said the opposite side, oops, what did I put there, is 2. The adjacent side, right, is root 7. So that's going to give me a far more accurate answer now than if I had worked out root 7 and used a decimal. Once again, to get rid of the tan, you use the inverse. So that's tan to the minus 1, 2 over root 7. And let's have a look at what that is. So shift tan 2 over root 7. So 37.1. Okay, so just break them up into sort of 2 separate triangles. What has the most information? So if you're looking at triangle B now, I can see if I try and find theta first, well, that's no good because I've only got one bit of information. So basically try and ignore that, and you're looking at this main triangle, and you've got a fair bit of information there. So I'm going to label that, right? That's my opposite to the angle. Here's my right angle, which makes that the hypotenuse. So what rule uses O and H? Well, that's sine. So we go sine theta equals opposite over hypotenuse. Sine 38 equals x over 10, and therefore x equals 10 sine 38. Again, this is going to be the difference between sometimes an A and an A plus. So x is 67.72. When I go to find theta, right? So this is opposite again over hypotenuse. So what have we got now? Again, we've got sine theta equals O over H, but this now becomes sine theta. Opposite is your x. Now instead of writing 67.72, I'm writing 10 sine 38. Oops, sorry, you can't, that just fits. It's the unrounded version over 8. And then theta will just be sine to the minus 1 of that. Notice I never use my calculator until the very end. And in fact, if I had just had all of this information and hadn't asked you to find x, I just asked you to find theta, I wouldn't have even written that answer in there. Right? And I wouldn't have had to use my calculator at all until this point here. That's what we want to try and head towards. So shift, sine, fraction button, we've got 10 sine 38 all over 8 equals. So we get 50.3. Done. How are we going for time? It's going to be a big video. So I had some people ask me about this question, find the value of x. Now, if we want x, we make our right angle triangle there, but we haven't got any other information. But if you go down here, right, this length here is going to be the same as that one, and we can actually find y first. Okay, so that's going to be, what's that, opposite hypotenuse, sorry for the opposite hypotenuse, so it's sine, so sine theta equals opposite over hypotenuse. Pop our information in, y over 3, so y is 3 sine 70, and because I'm using this in the next step, I am going to leave it like that. I'm not bothering to work it out. And again, over here we've got, that's your opposite, that's your hypotenuse. So once again, we're using sine. So if I now say sine theta equals opposite over hypotenuse, we've got sine 55. Now my opposite is the y, which is that, so that becomes 3 sine 70 all over x. And hey, x is downstairs. What happens when x is downstairs? If you forgot, then you scoot back up, you look at your example. What happens when it was downstairs? Oh yeah, we do the switcheroo. So that now becomes x equals 3 sine 70 over sine 55. Don't even think about cancelling these things here. You cannot do that. This is all calculator now. And away you go. B, try the same way. Again, we've got the parallel lines here. So technically, I would be saying you got the angle, you've got a length, which means you should be able to find this length here. You call that x. That will be the same here. And then you've got your right angle triangle, we've got opposite, we've got hypotenuse. So I'll leave that one for you. Hopefully that will be okay. Okay.